two projects. In this video, we are going to explain about the project that is Doctor or AI Efficient Neural Network for Response Classification in Health Consultations. Before getting into the execution, first let us understand what is the project about. In recent years, we have seen a rise in life threatening illness, and there are few reasons for this. Our lifestyles have changed, environmental factors are becoming more challenging, and the global spread of diseases like COVID 19 has added to the problem. All of this has put tremendous pressure on healthcare systems around the world. Hospitals they are overwhelmed with patients seeking care. At the same time, there aren't enough doctors and health professionals to keep up with the demand. This shortage makes it tough for doctors to provide timely care for everyone who needs it. And with this case, as a result, more and more people are turning to online platforms for medical help. These platforms often rely on artificial intelligence to provide fast, accessible responses to the people's questions. AI can be really helpful because it is available all the time, which is great when you are in need of quick answers. It can also handle large number of queries at once, which helps ease off some of the pressure on the healthcare system. But this AI is efficient, it lacks the personal touch that doctors bring. Doctors don't just give answers. They bring years of training, real world experiences, and the ability to make complex, nuanced decisions based on each patient's unique situation. AI, on the other hand, they can really offer general responses and it can't provide the same level of care or emotional support as the doctor. So while AI is valuable tool, it is not a substitute for the expertise and personalized care that doctors offer. As we rely more on AI in healthcare, it brings up some important concerns, especially when it comes to the trustworthiness of medical advice we get online. Medical information is often very complex and it can be difficult to know whether the response you are reading come from a doctor or from an AI. It is very important to know the response that we get is whether it is from the doctor or an AI system. This is where things get tricky because if we can't tell the difference, there is a real risk that where the information could be wrong, whether the information could be wrong. If AI gives inaccurate advice, it could harm patients and it could also make them lose trust in using online health services. We need to develop a better system that can accurately tell whether medical advice comes from a qualified doctor or from AI. If we don't address this issue, it can undermine the quality of healthcare and make people hesitant to rely on digital health platforms in the future. The goal here is not just to improve healthcare, but also to ensure that people feel confident and safe using these platforms, knowing that they can trust the advice they are receiving. So, to overcome from all these issues, this project designs a model called MedXNet to figure out whether a medical prescription comes from a doctor or an AI. Here, this is the combination of MedXNet is combination of multiple deep learning models that are BiLSTM, transformers, and Convivendi, which is a type of neural network. These algorithms, they are really good at understanding patterns in the sequence of words. They can capture both small details and the bigger picture when analyzing the text. So the way it works it that the system takes the text and converts into numbers using the technique called TF-IDF, which is a way of turning out words into vectors that capture their importance. Once that is done, the system uses set of layers. It uses fully connected layer, dropout layer, and softmax activation. So fully connected dense layer, this helps the system to learn from the data effectively and drop out regularization to make sure that it doesn't overfit, meaning it doesn't become too specific to the data it is trained on and it can generalize better. Finally, it uses softmax activation function, which helps in making a clear decision on whether the text is from a doctor or an AI, making the classification more accurate. And to see how well this MedXNet works, it is compared with the other different models that are BiLSTM and GRU, which are also used for analyzing the text. The main data set used to train the MedXNet is called MEDIC, which is taken from the Kaggle repository. This data set includes both the responses from doctor and also from AI. So the system can learn how to tell the difference between the two, whether the prescription is from the doctor or an AI. And what sets MedXNet apart is its ability to capture subtle details in the medical text, which is something other models might miss. By doing this, it outperforms the traditional models, offering a more reliable way to identify when a response is generated by AI. This means patients can use MedXNet to cross check their prescriptions, ensuring they're getting accurate, trustworthy information from healthcare professionals. Moving on, to further improve the performance, in this project, we are incorporating 2D convolutional neural network, that is CNN 2D, to the mix. This improvement helps the model to recognize more complex patterns in the data, which makes it even better at figuring out whether a prescription or a medical response comes from a doctor or an AI. By adding this layer, we're essentially giving the system a boost in terms of its accuracy and reliability. And additionally, we have built front end using Flask framework. So this will allow patients to easily interact with the system and check if there is prescription or a medical response was generated by AI or a doctor. The front end is designed to be user friendly and it will include a user secure authentication mechanism to protect sensitive medical information, ensuring that only authorized users can access it. This makes the whole process smoother and safer for patients using the system. Now let's move on to the implementation. So to implement this project, we have followed the steps mentioned in the flow of work. First, we have imported all the required libraries and packages. So for data manipulation, we have imported pandas and numpy. For text processing, we have imported NLP. And for model building, we have imported sklearn and TensorFlow. And for front-end purpose, we have used Flask. And then comes data exploration. In this step, we explore the data set to understand its structure, identify the target variable, and get an overview of the data distribution. It is very important to check for any issues like missing values or data imbalances in the data. Then comes data pre-processing here. Common words like the, is, a, etc. are removed as they don't contribute much to meaning of the text. Then comes punctuation removal. So punctuation marks are removed to clean the text and make it easier to process. And then comes stemming. Here it is reducing words to their base or root form. That is, from a word running, it becomes the word run. It is like that. Then comes the lemmatization. It is similar to stemming, but it reduces the words to their dictionary form. For example, if the word is better, it becomes good, like that. And then comes text vectorization. So this step converts the text data into numeric form that can be used by machine learning models. So the technique called TF-IDF and word embeddings are typically used here to represent words as vectors, and that vectors are normalized. So normalizing the vectors ensures that all features have the same scale, which is important for model performance. It typically involves scaling the feature values to a certain range or adjusting them to have a standard distribution. And coming to data splitting, we split the data into two subsets. One is training set and the other one is testing set. Training set is used to train the model and testing set is used to evaluate its performance. And then in this step, we choose and define machine learning models. Here we define deep learning models that are BiLSTM transformers and CNN depending on the problem. After that, the defined model is trained on the training data set where it learns to map input features, that is text, to the correct output, that is doctor generated or AI generated text. Then comes the model evaluation. All the models which are built are evaluated using accuracy, precision, recall, and reference code, and they are compared through graphs. Coming to the part of front end, so a user-friendly interface is created using Flask, and this involves setting up registration and login functionality along with the connecting to an SQLite database to store the user information. And in the front end, users they will be able to provide the prescription in the form of text, and that will be pre-processed at the back end. It will be fed with the trained model. Finally, outcome will be displayed through the front end, whether it is doctor-generated prescription or a AI-generated prescription. Moving on to algorithms used, these are the algorithms which are used in this project to classify the given text as doctor generated text or a AI generated text. So we have used BiLSTM GRE for comparison, and this is a proposed model MedXNet and the extension model CNN2D. So we have trained all these algorithms on the dataset. And moving on to the requirements, to implement this project, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we need to open the code folder which contains source code files. These are the source code files in the code folder of the project. Now let's understand what do we have in this files and how will they be used in this project. Let us open the dataset folder. So this is the main dataset that we have used in this project. It's loading, just wait for a while. So here the dataset has been opened. So here we have two kinds of prescriptions, two kinds of text that is doctor generated prescription, and here we have AI generated prescription. So we will be using all this text to train the model for classifying whether the given prescription is of doctors or an AI. Let's close this. And here in the test data file, we have the test cases that we will be using in the front end. Let's get back. And here in this model folder, algorithm information is stored in .h5 files, numpy files, and pickle files. And that will be loaded into the project code during runtime of the application. And here in the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then comes the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook.db file. Sorry, notebook.ibynb file. It is a Jupyter notebook file which contains combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And here in this signup.db file, this is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So to execute, we are supposed to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the command prompt. It has been opened. Give the command cd, give the space, paste the copied path, and now click on enter. So by giving the command and specifying the path, current directory is changed to the code folder's path. Now we are supposed to compile the app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So just wait for a while, it is being loaded. So here, this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. We need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click here. So here we are supposed to provide username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the test case file. Click on that. So this is the file that we're supposed to upload. Select it, click on open, and it has been loaded. Before uploading, let's see what do we have in that file. Get back to the code folder. Open the dataset folder, open the test data. So here we have multiple test cases. So these are the different prescriptions that we will be uploading now and see whether it is doctor prescription or a AI prescription. Let's get back to the application. Click on upload now. So the given text, it will be pre-processed at the backend, and then it will be fed with a trained model, and that trained model will be giving us a prediction. So here we got the prediction. So this is the first text that we have uploaded. This is the first message, that is the first prescription that we have uploaded. Based on that, here we got the prediction as AI response. So it is the AI generated text. And for the next given text, so this is the next given text, and here we got the prescription as here we got the prediction as AI response. So this message is generated by AI. And this third one is also AI. The fourth one, so this text which has been given is predicted as doctor response. So this is the prescription which is given by this doctor. So this text is generated by the doctor. And for the next text also, here we got the prediction as doctor. Remaining all the text, for the text we have uploaded, we got the prediction. If it is generated by AI, it will predict it as AI. If it is by doctor, if the text has been generated given by doctor, it will give the prediction as doctor. Now let's check with the graphs. Click on graph. So here we have the graph. So this is the confusion matrix of the extension model CNN 2D, and this is the extension CNN 2D's ROC AUC curve graph. And here on x-axis we have false positive rate, and on y-axis we have true positive rate. Moving on, this is the accuracy score comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithms which are trained on the data set to classify the text as doctor generated response or a AI generated response. And here we have precision score comparison graph. And this is the recall score. This is the FN score. Accuracy, precision, recall, and FN score are the metrics used to evaluate the classification models. Now click on sign out. In this widget, by giving text to the application, it will predict whether the given text is doctor generated or an AI generated text it is. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.